A while back, I spent some time thinking a lot about how we provide access to our systems. And that's actually quite challenging because historically, HPC systems are command line. You log in through SSH, you compile your highly optimized Fortran program, and then you write a job script and submit it to a batch system, wait for it to run, and get your job output back later and do your analysis. And that requires a lot of interacting with Unix, which I really like. I think, well, I mean, you can see from the videos I run Linux on my desktop, and I have done for a long time. Um, but it's really a barrier to entry for a lot of people. And I want to be careful about what I'm talking about, because I think a lot of the time when you say you want to make access to HPC systems more user-friendly, people think, well, the best thing to do is to put a GUI in and then turn it into the kind of point and clicky experience that is terrible for reproducibility and reproducible science, and is generally terrible to manage. One of the things I've been pondering for a while is Python as a front end to HPC, and specifically, a lot of our users want to use a thing called Jupyter. We're looking at various ways that we might present that as a login node. But I was kind of interested to see whether we could get away with interacting with the scheduler in the same way. So I did a little mock-up. This is an idea I've had for a while, actually, so far back that I fund is the wrong word. I supervised an MSc project to do this back in 2021, which didn't quite go where I wanted it to go, I think. But the basic idea is, rather than interacting with Unix, you would interact with Python, right? So you still write code, you still write job scripts, everything would still be automatable, but you would not have to learn Bash. You wouldn't, because you can transfer files through Jupyter, you don't have to learn to use SFTP or anything like that. You open a web browser and you can write Python programs that submit jobs. So what do we have to do to enable that, right? I should point out this is a mock-up. There's a repo here on GitHub you can look at. I do not recommend you use this. I do actually use it for something. I'll talk about that later. But what I thought we needed really was something that represented. So the current process, right, is a user logs in. They create a job script. That goes into the scheduler and is run on the HPC system. They get their output, right? I wanted the model for Python to be different. I wanted them to, either a Python prompt or in a notebook, produce an object, right? I don't know what the right way to draw an object is in this, but just pretend this cube is, this really badly proportioned cube is an object. And that would be a Python object that you would construct, would have properties, and then that would then produce this, right? And then you'd be able to get your output back. So I set about a plan. I created a bunch of stuff in a Python library. Specifically, there's inside. So I do a bad thing when I create Python libraries. I tend to put everything inside underscore underscore into underscore, which you should not do. You should structure things properly. And I created a class which I've called the job, right? Which describes most of the things that we have in a job script. So it's things like the name, how much memory it wants, how long it wants to run for, which modules it uses, whether it's parallel, that sort of thing. And has a bunch of methods to change these properties. So once you've got your job object, right, you can manipulate it in Python so that you can change its behavior. And then because this is even before a proof of concept, a kind of me mucking about, a thing to actually generate the job script so we can look at it to see how reasonable it is, called get job script, that produces a string, and then very awkwardly, and this is definitely a thing you should not do as a design, right? There's a different class for jobs that are in the queue, but that should not be the case. That's because you're writing stuff and you're desperately trying to get things to work. What else is there in here? There's a bunch of classes to allow you to add serial and parallel commands to your script. This is the closest you get to writing Bash. In that there is one for user script where you can directly insert Bash script into your script. There's a second part here which I called the executor. This is the bit that talks to Grid Engine. So and it talks to it in a very bad way. So it literally wraps Grid Engine shell commands, right? Grid Engine, I think, implements an API called DRMAA, which you could use to do this. But I didn't really have the energy to learn that when I was just trying to prove that this works. And also, I think Slurm doesn't do that. And we're thinking about moving to Slurm, and I just really want to see if this concept works at all. So Executor has a bunch of tools for interacting with a job. The usual ones, right? Submitting, deleting, checking the status of it, getting a list of all the jobs, and just a quick wrapper to make it easy to run commands, because for some reason subprocess.run is not the nicest thing for wrapping commands. And then the final thing I thought would be really neat to show off when I was doing this like proof of concept work was, obviously if you've got a job class, you can then subclass that and have specific types of jobs. So here I've got a Python. The Python job actually does the thing we've talked about in the past, which is, if you remember the Shell Scripts of Madness video, it generates a Python script that runs as a job script. I've done one which runs HPL. I've done one which runs lamps. Specifically, the lamps one is interesting because this is the test example I show everyone where you go, right. So I can, as a non-Bash person, I can create a lamps job in Python, submit it, and get my results back, right? And there are other libraries you can actually get which let you deal with the output of lamps. And going back to that master student project, one of the things I got him to do was play back with some of those as well. Right, so what does this look like? So here I have set up Jupyter Lab on Myriad. I've port forwarded it to the loopback interface on my machine. Obviously, in the real production world, this would be behind something like Open on Demand, or just in a containerized thing where you went through the web and got access to your Jupyter Hub. Right. So we want to start a new notebook. Now I believe that the Gepy stuff should all be in here because I went through the machinations of setting up the virtual env properly. So it's been about a year since I wrote this. What do we have to do? Well, we need to import Gepy. So make sure that works. Okay. So let's create like a simple job, right? We'll call this simple job equals Gepy job. If we go back to here in the init, when we define job, there's a whole bunch of things we can define at the start, which are its name, how much memory it has, how long it's going to run, and whether the current working directory is the correct directory or a specific one. By default, it just has some base ones of those. So if we do that, and then we do print simple job dot get. Another one of my programming tics is I constantly switch between like camel case, snake case, and just whatever, depending on the project. And it makes it very hard for me when I'm coming back to things to work out what I'm doing. Right, okay, fine. Right, so what this should do, right, is it should create the skeleton job and it should print out what the job script looks like. There we go. So the most basic job you can create has a shebang, has a comment that says, this is all Owen's fault, has the name Gepy job, 1 gig of RAM, 1 hour runtime, and runs in the current working directory. Obviously this job doesn't do anything, it just starts up. So let's add something to it. So say we wanted to run, say we had a different Python script, right? And we'll call the Python script hello.py. It doesn't really exist yet. I believe we could actually create this. Let's do this. New file. Let's do this live. hello.py. I believe we can edit this. Print hello from myriad. Okay. Brief moment of horrors. I try to remember whether there are semicolons in Python there or not. Right. Again, one of the problems with using too many programming languages. Right. So we want to run a Python script, right? So we can do simple job. And again, this is not the greatest interface for this because I probably would be better Python. So here, again, I've effectively, in this design, because I'm chucking stuff together, or was chucking stuff together, I gave direct access to the modules, I think. Yeah, it's got self.modules, okay. What that will do is add that module to the list, and then simple job append. What's the right way to do this? This has been a while since I've done this. So I'll quickly look at Python. So we want to append a serial command. How do we do that? I think, again, this might be a thing where I've just given it direct access. Yes. So what did I call the thing? It's probably its workload. Okay. Dot workload. Right, that works. And then if we print out the job script again, what have I done there? I appended that wrong. It should be append serial commands. See, this is why you should always dry run things. I'm genuinely not dry running them. Okay, this is actually more structured than I remember. That should be correct. We need to go up one more bracket. Okay, let's run that again. So restart the kernel. What have I done there? There we go. So you can see we have the original job script, which is like the barest version of it. We've asked it to add in a module. It's added in a module in the right place. It's added in Python, the commands. Because these are separate lists, all the modules will be added at the start of the job, then it will run all your commands, right? So that's a little bit of flexibility that you lose, but that's life. And in fact, the thing we can do now is we can submit this, right? Right. Okay. Now, so I definitely need to remember how the hell this works. I think we do. Oops. Start. Q sub. Simple job. And again, this is something where if I'd been designing this, I certainly would not like part of the point is the user shouldn't really see the job script, right? So this in reality, in a more productionized version, you would have it just read this from the simple job. But if we run that, what we get back is a job ID. Right. Now, if we do QStat. So the reason it's an array is because obviously if you have an array job, you get stuff like the number of tasks and things like that. If we do QStat job, now this is messy, right? This should really come out as we'll see that that's a Getty job, right? We get a job back. It's one of those Q jobs that we talked about. So it's a different class, and again, I don't like that. That would be the kind of thing you'd want to tidy up if you had a software engineer actually doing this rather than me. But for example, we could get back its status. And I've screwed that up. Oh, it's a list. Why is it a list? Q job. List object. Where is it? I think it's almost. Let's see what red says. Oh, that's very annoying. Oh, I know what's going on. Of course, because it can be arrays, I've written it so that it can return multiple things, because there could be multiple copies of the job. Okay. There we go. And that job is running, right? And so the whole point is you can generally control a scheduler through this. Right. I would quite like to do a lamps example, but I have to have a break now because I've got a meeting. So. Right, so that job run, we've got, let's just check, update the status. Still says it's running. There's a bit of lag in the queue generally, so the scheduler loops over all the jobs and eventually, and then it updates the status of them, so they're not necessarily up to date. So it still thinks it's running, but it's actually finished. If we open the .o file it's generated, there we go, we've got hello from Myriad in there. So that worked. Okay. The next thing I'd quite like to show off is the whole point of the class thing, right? So let's do another job. So we'll call this ljob equals, we need to import template, don't we? Import Geppy template st. Okay. And we'll say ljob equals t dot job. So we'll see what the most basic lamps job looks like, right? And then print. From here we see that when you create a lamps job, it already has a whole bunch of stuff set up. It knows that it needs to have probably 4 gigs of RAM per process. It knows it's probably an MPI program, although it's only given it for 1 core. It also knows that lamps has a whole bunch, there's a default version of lamps it's selected. There's a whole bunch of modules it needs to load. One of the things a lamps job needs is an input file. We've not given it the input file. So let's get some input files, I think would be a good plan, wouldn't it? Let's think about that. What's the best way to do that? Oh, one of the nice things about Jupyter is you could just start a shell. So I'm pretty sure I've done a demo like this for someone else in person. So let's just see if there's a Gepy lamps job in there. No, it's not. Oh, that's annoying. It might be on another machine. Right. So lamps comes with a set of benchmarks and stuff. So let's just pull those in. So if we, what was the module called? Oops. Oops. One of the problems with being me and being quite old is that GUIs are a constant source of pain. If we look in here, you can tell I've been using Windows because I keep trying to do Shift Control C to copy and paste. Right, let's do this again. There we go. You'll see that there's a folder in there called Bench. And what we want to do is pull in all of the bits that are Rodo. So the Rodospin benchmark, I've probably talked about this elsewhere, is just a protein that's in the eye. And it's provided with lamps as a benchmark. And it runs really quickly. So if we copy, again, too much Windows. What do we need? We need in.rodo and we need data.rodo. So start.rodo probably did it. Right, we now have the bits for the Rodo stuff. Oh, we don't need those logs. Right. So, going back to the demo, this needs an input file. If we look at the templates, we need to say so that's interesting. So I've done this in a bad way. It looks like we can't set it afterwards necessarily. So let's do this differently. So we need to set, looks like we need to set the input file up when we create the object. So let's do that. So did I put an underscore? See, there's a typical me thing, not put underscores. And we'll call it in.rodo. And now when we run it, right, it creates the right job script. Right. One other thing, okay. We could change the number of cores. We could turn on and off SMT. Myriad doesn't let you use SMT, but I intended this to be general, so it should run on the other things you turn on SMT. But the point is, ignoring the print job scripts, right? If we take that out, the interaction the user has with it is create a lamps job and then submit it. Right. Next up, QStat. Is QStat the right command? QStat job. Right, so the job is pending. And, you know, the gore of this being very much me mucking about and trying to get this to work rather than trying to design something is, you know, you've got all these bits out of lists and so on. But, you know, the user has created a job script, has created a LAMPS job just by saying, I want to create a LAMPS job to run this input file. Geppi has created an appropriate job script, which you can then submitted it. And it's now in the queue, right? And it will run, like that's a valid LAMPS job script, and you will be able to get your output. And so this was me trying, so in the end, like the goal here, right, is to say, can we control this from Python? It looks like the LAMPS job output file has been created. There's a little trip, which means it's probably running. Yep. But I've done this in Jupyter to show off, you know, really to be provocative and say, look, you don't need to have a command line to control this, right? You could produce Python, and in fact, you can produce Python to do this. So I do actually use this library, even though you shouldn't, to do one thing, which is that NVIDIA releases new versions of its toolkit every few months. And because of the inherent difficulties in supporting GPUs to do with differences between driver, CUDA, Fortran, CUDA Fortran, that's what I'm looking for, do concurrent support, and OpenMP, OpenACC, what I've done is I've done a little set of regression tests in Python, so I've got a little script that I can run. Don't know if this worth showing. I think actually it might even be in the repository. I've got a little set of scripts that I run basically whenever a copy of this, you know, whenever there's a new release of the toolkit, here we go. I run these tests, right? I've got a test script here, and you give it an argument, which is what is the name of the new compiler module. It checks out, you know, the repo we have all the Py examples. Well, there's a version for each of those languages in there, so it checks out. So the job checks out that repo. Here we go. So we create a template job. We go to name, tell it which modules to load. Testing, personal ones and testing modules are where I do test installs of the compiler before I push them out. It builds up a job script with the executor stuff, right? Actually, it's better than that. It directly uses executor to clone out the repo. Creates the job script, submits the job, submits a version for do concurrent, CUDA Fortran, OMP, and OpenACC. And then, so I just run, so when I put in a new version of the HPC SDK, I do an install in my home directory and run this script with that as an argument, and we can do that. So if we do, okay. You can actually see historical ones I've done with previous version. Let's do one of the production ones, because so if we do Python 3 examples NV test and then give it the 22.9 module. Oops. Again, I'm being screwed by this not being a proper terminal. So by default, it does 21.11, right? Okay. If I run this with compilers, NVIDIA, HPC, SDK, 22.9. There we go. So it produces the job scripts. We can actually see what those scripts look like. Start. Right, it does exactly what we said. It sets the name appropriately. You see it's all using Gepy to build up the commands. And this way I just automate it, so I can just run those tests and see if they passed or failed at the end. And if they passed, they're fine. If they failed, I probably have to mess about with some of the settings or ask systems teams to update the drivers on the nodes. So yeah, this is cool. I quite like it. I think, obviously, there is zero chance of us putting this into production on Myriad as it stands. One of the things I've been trying to decide is whether it is worth spending time making this work better. Certainly we need to be rewritten anyway, because we're going to move to something that is not Grid Engine in the near future, because Grid Engine is definitely historical reenactment software. But I think, the concept works, certainly, and it was a nice little project for me to do.